Hello everyone, welcome back to Alex Does LeetCode. As I, with you, work on LeetCode problems on stream. I've been thinking about what is a good summary for what this channel does, and I think that's a pretty good thing to land on. I work on LeetCode problems with you on stream. If you want to get the most out of this channel, my suggestion is to join me and work on those problems alongside me and not just watch me do it passively. At the end of the day, if you want to learn something, you can't just watch someone else do it. You have to get in there and do it yourself. Okay, alright. Now, we're back to our LeetCode 75 and we are going to pick another problem today. Are there hard problems? I'm curious. There are no hard problems. What's a monotonic stack? Wow. Okay, you know what? We're gonna pick a funky sounding problem right here at the end. Minimum number of arrows to burst balloons. This sounds pretty interesting, right? Okay, let's see what we got here. Alright, as usual, we're gonna start by reading the prompt. It says here, minimum number of arrows to burst balloons. There are some spherical balloons taped onto a flat wall that represents XY plane. The balloons are represented as 2D integer array points. Okay, so it says an integer array, but it's actually a pair, right? It's just an array of length 2. Yeah. Oh wait, no. Oh no, I got that wrong. So it's an array of arrays. Okay? So points is an array with multiple things in it, and each element in point represents a balloon. Points x, y, x start, xn. I'm a little represents a balloon whose horizontal diameter stretch between x start and xn. Okay, so arrows can be shot up vertically in a positive y direction from different points along the x-axis. I see. There's no limit to the number of the arrows that can be shot. Okay, so the picture looks a bit like this. Imagine you got a balloon here, right? X start, xn. This is one fat balloon. Maybe you have another balloon here. Okay, you can think of this as a circle. You don't know where they are, right? And in a sense, where they are horizontally doesn't matter. Okay, and then you got another balloon here. Maybe one more balloon here. Okay, I'm just gonna overlap just a little bit. Okay, cool. Right? So you have 4 balloons. It's a bit weird. You just so imagine they're round circles with me. Okay, they're round circles. Now, if you shoot an arrow, let's say here. Where's my arrow? I'm too invested in this cursor art to just half-ass it. You know, I could just like A for arrow. Actually, A makes a pretty good arrow. You know what? I'm gonna go A for arrow. And then I need an upside down V or something. I'm very invested. As you can see, I'm very invested in this. Aha! Arrow. There we go. Okay, so you've got an arrow here. It's gonna travel up this way. Let me just make sure I have a bunch of blank spaces. It's gonna travel up this way. Oh, it doesn't let me blank spaces. It's gonna travel up this way, right? It's gonna go up and it's gonna miss all the balloons. Whereas, that was very anticlimactic. I'm like, oh, I'm gonna travel up this way, miss all the balloons. Okay, Whereas if your arrow was somewhere, let's say here, it's gonna go up and it's gonna hit both of these balloons and it's gonna pop both of them. Alright, so this is how it works. Now, versus, let's say, I'll give one more example. You guys probably don't need it, but I am too invested in moving my arrow. Okay, I'm gonna move it a little bit here. Okay, cool. Cool beans. Okay, versus an arrow here, it's gonna pop this one balloon right here. This balloon will get popped by this arrow. Okay? So basically, we have to calculate the minimum number of arrows that must be shot to burst all balloons. In this picture that I have, the minimum number of arrows that I can see is 2. You shoot one at somewhere around this vertical over here, and then shoot another one that then it pops these two guys, and then shoot another one around here, like right here, and then pop these two guys, right? I really like my balloons. Yeah. So you need 2 arrows. If you have both of these arrows, you pop all the balloons. Okay, so we have to calculate the minimum number of arrows needed to pop all the balloons, given their XY ranges, which is given over here. Okay, the first thing I'm thinking of. The first thing I'm thinking of is the first thing I'm thinking of actually is not even a solution to the problem, right? The first thing I'm thinking of is that we can actually collapse the balloons. I think that at some point I'm going to go along the x-axis and test each location, each like firing site, right? I have to test each firing site. So if I want to do that, then imagine I have a balloon that is like 1 to 500,000. That's not going to be a fun balloon. I'm going to test a firing site. That's not going to be a fun balloon to have. So instead of dealing with one point at a time, it doesn't matter. Take for example this place, right? From here to here, it doesn't matter where I fire, because this is a place. This is start of one balloon, and this is. This is the start of the next balloon. So it doesn't matter how far I fire. Okay, that's one night. Let's write down our tactics here. 1. Collapse the balloons into intervals. So that what I mean by that is, instead of having 2 balloons like this, I'm going to say there's a balloon, there's another balloon, right? So something like this. So essentially these 2 balloons have 3 intervals. Just this top balloon, something in between where it hits both balloons, and then one area there's no balloons. So the first thing I'm thinking of is, actually I should move my face to somewhere else. I need to find a good place for my face. Or maybe I should get rid of my face. I don't know what value my face brings. Um, to this whole experience. Okay, so let me see. The other thing I'm thinking of is I can either collapse into intervals, or at least think of them as intervals. The other thing I can do is to sort the balloons. This is actually not obvious how I would do it, right? I could sort the balloons by their start point, or I could sort by their end point. So it's not super clear what I should do yet. I don't think it matters. I don't think it matters if I am sorting them by their start or end point. But one thing that does matter, one thing that absolutely does matter, is that with one side sorted, the other side is slightly not sorted. Okay, so we're gonna sort the balloon. We're gonna sort the balloons. So the first idea I have is really a greedy algorithm. Okay, it's greedy. It's a greedy algorithm. Actually, let's not deal with the collapsing first. Let's not deal with collapsing first. Let's just start by sorting the balloons. Okay. We can optimize it by doing the intervals later. But let's start by sorting the balloons. So the balloons, if I sort it, would look something like this, based on their left hand, their start, right, the left hand side. And so if I sort the balloons like this, then one thing I might do, okay, since I need to pop all the balloons, okay, so I have a bunch of arrows, right? Okay, here's what I'm thinking of. So I've got a bunch of arrows, right? Okay, I don't know where the arrows are. They're like somewhere. Okay, this is a terrible arrangement of arrows. But since I need to pop the balloons, one thing I know is true. If I have if I don't have an arrow between an interval, then I'm screwed. Okay, if I don't have an arrow between an interval, that means I'm screwed. Something has gone wrong. So I need to fire a balloon. I need to fire arrow before the interval ends. And let me explain this is how my thought process works. Let's say I'm here, I'm like moving my arrow, right? So let's say I start from the extreme left side, I'm moving my arrow. Does this work? So I'm like, can I fire here? Yeah, sure. Must I fire here? Maybe not, right? I keep going, right? If I fire here, I get 2 balloons. Oh, that's kind of nice. Is it definitely a place I need to fire? We could keep looking for better. And we keep going, right? And we come here. Alright, now we can pop 3 balloons. That's great. That's even better than before. But must we fire here? Not true. Let's say once we get to this spot. At this spot, we can pop all 3 balloons. Must I fire here? Well, actually I do. Because if I move one more down, then this balloon is never gonna get popped. Okay? Because I've sorted everybody by their left hand side, right? So if I move beyond the first if I sort everybody by their start, if I move beyond the first end, that means that this guy is never gonna get popped. I'm gonna have to put a balloon to an arrow somewhere here. Okay? The soonest I can do this is here, but the latest I can do it is here. So I'm guaranteed no matter what, I need an arrow somewhere between here and here. And because additionally I know the other thing I know is that everybody, like, let's call this balloon 1. This is gonna be terrible. 1, balloon 2, balloon 3, 4, 5. Okay, everybody before balloon 3 started before me and ends after me because I'm the first one to end, right? Everybody before balloon 3 starts before me and ends after me. And ends after me. I need to find an arrow here. Okay. And by firing an arrow here, I'm going to pop everybody before me. Yeah, so that's going to be my algorithm. So step 1, okay, the collapse the balloon to intervals is still a good idea. I'm going to solve this problem twice. I'm going to try the way that I think is the sort of simpler but less complex without the collapsing. And I'm going to try by the start. Okay, step 2 is keep moving, increasing a counter. It's the end for any balloon. Pop all for balloon and pop all balloons and smaller. Okay, so that's going to be my strategy, or specifically popped. Okay, all balloons up to n is popped. So this balloon is considered popped and everybody else before it. And now I keep doing the same thing again. I continue. Okay, so I think this works. I think this strategy works. And I think this will give us the optimal solution. Okay, so we're gonna we are going to first we're gonna sort points. Okay, and so Python has good algorithms for sorting a list. I don't remember what exactly. Okay, so now we all know how to sort a list of points, right? That's very simple. Actually, let me just make sure I didn't mess it up. Yeah. Okay, you all know how to sort a list of points, list of things. Okay, but sorting by the lists by the first point. Actually, I think I can just do this. I don't need any special comparator. So what do I mean by comparator? When you want to sort numbers, right? Let me just do a little digression here. It's pretty obvious how we want to sort it. There's only one way to sort it. There is only one way. Bigger numbers go in front, or bigger numbers, we sort them by size. we sort by size, right? There's no other way we sort numbers. We don't say, oh, you know, special pattern where we sort all the odd numbers first but even numbers later. But we sort things that are not numbers. There's a default way, not a one way. There's a default way to do things, so we sort it by size. But sometimes we want to sort things that don't have a default sorting order. We want to sort things that don't have a default. For instance, lists and dictionaries. Yeah. So that's when you need to use this key function. This key function. Let me see if I have an example of key. Key was my func. Okay, so for instance here, cars, Ford, Mitsubishi, BMW, Volkswagen. Okay, if you just say cars.sort, it's going to sort them the normal way. And the default way we sort strings is alphabetically. Okay, so the default way we sort a string is just, you know, alphabetically. Right? This is so slow. Come on, guys. Yeah, BFMV. Okay, so let's say we want a special way of sorting things. We don't want you to use the default sorting order. We want our own special order. That's when we define a key function. We do it like this. The key function takes E. Interesting. So a key function basically takes the element E and returns, I guess in this case, a number or something else that helps you determine the order. So for instance, the key function here will be my func. Key function here will take the element and return its length. So when sorting, instead of sorting Ford, Mitsubishi, BMW, Volkswagen, it will sort 4, which is the length of Ford. 1, 3, 4, 5, 6, 7, 8, 9, 10, 10, 3, and 2. And this was basically sort the lists of cars here by their length, by the length of their name. And it looks something like this. This is interesting. I didn't actually realize this, but in some other languages, notably Java, instead of defining a key function, you define a comparator. In Java, Java, it's Java down in Mexico. Yeah. So for instance, greater than will be a comparator. Okay, so back to this. Actually, before we go back, I'm pretty sure that the default sorting function would sort arrays by their first element, but let's try it out. 1, 2, 3, yep. So it looks like it's doing the right thing. So I'm going to trust that it's doing the right thing here. So I just do points dot sort. Okay. This sorts points by the elements first element. Because remember, points is a list of lists, right? Points is a list of lists. Points is a list of lists. So we get something like this. So now we go through Now here's the tricky part. We need to look at all their second elements. Actually, we need the first element. We don't actually need the first element. We have sorted them by the first element. So we just need the second element. Okay? So now we do a little transformation. Oh, we don't even need to do the collapsing thing. We do a little transformation of points.sort. So taking this example over here, points.sort will give us one, 2, 7, 10. Okay. So because I don't want the first element, I want to transform this into 6, 8, 12, 16. Wait a second. Wait, is my algorithm right? Oh, my algorithm is not correct. I do need the right hand side. Okay, interesting. So I do need the right hand side. 2, 8. Okay, let's come back to the drawing board a little bit. Ah, damn it. 7, 12, and then 10, 16. Okay, I've sorted them by their left hand side. I know I need to hit a balloon here. Oh, interesting. So gotcha. So here's the bug. This is not bug all balloons up to n has popped. Okay, I'm going to need 2 counters here. Pop the following. Pop balloons up to balloon whose start is smaller or equal to n.n is popped. Okay. So I got the balloon firing algorithm right? But the popping is wrong. So basically it works like this. I start from here, I keep going, I see 6. Uh-oh, if I don't fire an arrow at 6, what's going to happen? Well, balloon 1 will never be popped. So I know I have to fire an arrow at 6. Right? I need to fire an arrow at 6. At this place. Or else balloon 1 will never be popped. Okay? And that has the effect of popping both balloon 1 and balloon 2. Interesting. Okay. So basically, I think the algorithm is as follows. After I sort them, okay, let's do it the simple way first. So for I in range, so first I need to find the max. And so to do that, I say ends equals, let's extract all the ends because we're going to need it later. So to extract all the ends, so what I mean by extracting all the ends is we need 6, 8, 12, 16, okay? The ends. We just take the same list here but extract all the ends. So Python has this thing called list comprehension, and it's a very Pythonic way of doing things. So it has a very convenient way of extracting all the ends. And in general, you should try to use these built-in Pythonic idioms, because not only are they easier to read, they're easier to write, they are also often faster. So the way to do that is Python list comprehension. Okay, here's a good example. I think it's like yeah, so this is the basic idea without comprehension. You do a for loop, right? That's the basic idea. So the list comprehension looks something like this. Ends equals to n for n in oh wait, ends equals p, so e1 in points for e in points. Okay, so for each element, let's spell that properly. For each element in points, I'm going to take the element colon 1. Actually, let's do it properly. Let's say what elements are. So these points are basically a list of balloons. For each balloon in points, I'm going to take the end of the balloon. So each balloon is a array of list 2, list of length 2. So I'm going to take the second thing in ends. Okay, so ends. So ends.max. Is that how to do it? From list. I think it's like max. Yeah, max list. So it's not like this, it's just max ends. Okay, so this will tell me the max ends n. Okay, so basically max n is here, is this 16 over here, right? It's so in our example, the balloon with the largest start also has the largest end, but this is not true in the general case. So for instance, this balloon has the lowest start but it has the largest end. So our goal is to find the largest end. So our algorithm does not keep going indefinitely. Okay, so in max range, okay, we're going to check, are we let's see, this is not the best way of doing things. I thought it would be simpler, but it may not. So I want to explain what I'm doing. So basically I'm moving this a here. Why don't I do like this for a in range, so we're clear what we're moving. I like this a. I think it's a happy coincidence that a can it's such a beautiful arrowhead. So we're moving a down. We're gonna keep moving a down. Every time we find a place that we should fire, we'll fire here. Pow, and we'll hit all these guys. Okay? So that's what we're gonna do. We're moving a. And now I've sorted balloon. I just need to figure out how. Okay. the end of any balloon. Okay, are we at the end of any balloon? So to find if we're at the end of any balloon, oh, we can use ends. How fortunate. So again, we can find in list Python. I think there's a convenient way to do this. So the thing about Python is basically try not to do anything on your own. There should be a built-in function that does basically anything you want. Find index, okay? The name of the function is index. Item start end. I'm pretty sure start and end is optional. Yeah, start and end are optional. So list.index and item. So we're gonna say ends dot index a. So we're gonna check, are we at the end of any balloon? And what does it return? Oh, interesting. Okay. Okay, we're gonna check. Now, this is a little bit tricky. This is a little bit tricky because we are looking any unpopped balloon. Okay. We're looking for the end of any unpopped balloon. We're on the right side of any unpopped balloon. So for instance, if you know one that nothing is popped, then A, when we are here, when A equals to 6, we are on the right side, the right edge of this unpopped balloon. If we go any further, then that balloon will never be popped. So which will be a problem. So we know that we have to stop and fire when we're at the edge of an unpopped balloon. Okay, but now this is very tricky. This is very tricky because let me give you an example. Let's say these two balloons are popped. Okay. Let's do this. Okay. Let's say a fire arrow at A equals to 6. Okay. So this pops 1 and 2. Alright. Let's say there's an arrow 3.5 at 8 to 10. Okay. So I'm going to get to 10. When A equals to 10, I'm going to think, I need to find ends.index. Okay, and ends.index is this guy over here. You're like, is he unpopped? Ends.index, is he here? Oh, well, it's popped. Let's move on. So we can't move on. We can't move on. We have to find if there are any unpopped balloons. So ends.index will just find the first balloon. Okay, ends.index will find the first balloon. So it's good programming practice to isolate. So the reason why I'm defining a new function is that I can see that it's going to be a bit tricky to find the first unpopped balloon. Basically, you have to say ends.index if this is not popped, then ends.index, like I equals ai plus 1. Yeah, we'll keep going. Right, we already see some annoying stuff here. We're going to put this in a loop while. So to make it a little bit simpler, it's a good coding practice to put things in a separate function. This makes your code a lot more readable. Fine. Okay. Matching unpopped. Okay, and 2. I need to pass this in. I need to pass let me see. I need to pass ends in. Yeah. And I also need to pass no, sorry. Pop in. And so what we do is while is I equals to ends dot index A, while I is an index, we say matching here because we want to find a matching balloon whose right side, let's comment this, find a balloon whose end matches an unpopped balloon. If there's no such balloon, then if there is no such balloon, return -1. Okay, so balloon equals ends dot unpop. While balloon is greater than popped, okay, means that this balloon has, oh sorry, smaller or equals to popped. Balloon equals to balloon plus 1. So we're going to find again if, okay, what happens if it doesn't find? Oh, it's an error value. So try accept. Okay, so we don't have to do this. Try accept return -1. Balloon. Okay, so we don't have to check that balloon is valid, because if at any point any of these ends dot indexes return any ends dot indexes doesn't match A, it's going to return -1. Okay, so now we can just do equals to find matching unpop. This is annoying to me because in about 5 minutes, when we're done with this code, we can rewrite all of it to make it a little bit better. Okay, but it's okay because this is ultimately a teaching channel, so I think the more code we write, the better, isn't it? Isn't that right, chat? I do believe that that is right. Unpopped A. What else? I need ends. I need popped. So popped, I've not talked about pop, okay? So the idea here is that because the balloons are sorted by their start, they're sorted, when we pop a balloon, we pop everything before it, okay? If we pop a balloon and we miss something, if another balloon whose left hand side is before our current balloon that we popped doesn't get popped, that's going to be a problem because the guy will never be popped. Okay, so for instance, if we pop 3, everybody before 3 has to have already been popped. If we pop 3, and so we pop 3 by going to its end, right? That's the only time we fire an arrow. We pop 3 and there's a, like, this guy hasn't been popped, then it's never going to be popped. Okay? Because we probably missed it, and we probably should have fired an arrow at 10 instead. Okay. So balloon equals unpopped if balloon equals -1, then we can continue, go find the next A. So if balloon is not -1, that means we're popping. Alright, then we fired 0, arrows fired equals 0, pop equals -1, okay, then we got to pop him, arrows fired equals plus equals 1, and popped equals balloon. Nope. So this is what I was doing before. Previous bug. Okay. So this is my previous bug. When I said when the counter hits the end for balloon end, pop balloons up to end. This is what I was doing. But that's wrong. I need to pop all balloons whose start is smaller or equals to n, let's just call it x. Balloon, let's just, you know what, balloon B for balloon. That's nice. B dot end. So I need to find, so pop doesn't need, instead pop equals to okay, largest balloon whose start equals to pop. Let's see if I can larger than something. Find smallest element greater than k. Okay, so it turns out that we do have a Pythonic library function that will help us here. So we're going to do that. And the Pythonic library function min. What? Oh. That's not helpful. This is not actually helpful because it's giving us the element. We don't want the element, we want the index. Can we do list comprehension with index? There we go. Here. So this is what we want. We're going to have another funky looking list comprehension thing to help us. Index. Yes, I like IDX for index. Index X in enumerate. So you know what? We need starts. 0. We need starts and ends. So ends will be this thing over here. Okay. We need the same thing starts. Okay. So now we want to find the largest balloon whose start is smaller than balloon, which is this guy over here. Here starts if actually, you know what? This is more trouble than it's worth. Let's do a good old-fashioned for loop. For I in range, because it's actually a slice, so starts 0, comma, yeah, do starts. Let's do this. We'll do this properly in a second. So length I in starts. Okay. If I is larger, so the algorithm is, let's come back to algorithm. If start is smaller than b dot n, if smaller equals to balloon, which is b on n, popped equals I. Okay, else break. So I is in starts. I will go along starts if, yeah, let's take this as an example. Starts is over here. Starts is basically 1, 2, go. Let's ignore this. Starts is basically so the first arrow when you fire, a equals to 6. Okay, at a equals to 6, popped equals, originally popped equals -1. Okay, and a equals to 6. So we want pop to be 1. So what we do is here, balloon will equals to 0. Okay, because when we reach 6, that's the right side of first unpopped balloon, which is balloon 0. We should actually name these things properly. Balloon 0, okay? And popped, we want it to be 0, right? And so algorithm says, how do I collapse things? Can I collapse things? Not the way I want it to. Okay, alright, that's fine. That's fine. For I in starts, I is smaller equals to balloon, popped equals to I. So I in starts is 0, 1. Smaller equals to balloon, yes. Smaller equals to balloon, yes. Okay. Oh, dx equals to index. So we go here. Is this smaller equals to balloon? Balloon is, oh, again, it's not 0. Balloon is the index, right? This is where having good names come in. I should have said balloon equals, so if I here balloon equals to 6. Actually, it's the same as A. Yeah, I'm not gonna touch A because we're gonna change that soon. Okay, so popped equals to first it's gonna check is this right hand side left hand side smaller than 6? Yes. Let's keep going. Is this left hand side smaller than 6? Not right hand side but left hand side. 2. Is it? Yes, it is. So we're popping both balloon 1 and popping balloon 2. We got to first two balloons. We go up to balloon number 2. We check is this left hand side smaller than A equals 6 where we're finding the arrow? Well, it's not. Okay. So we're gonna get to index equals 2 and break. So popped will be equals to 1. So that's what happens at the end of the first cycle. Okay. Arrows fired. Pop all balloons whose start is smaller or equals to A. Enter balloon, which is A. Okay, but I'm not going to use A because we're going to change things up a little bit. Okay, we can actually optimize this a little bit. I think this will work. Okay, I will keep doing this. We keep doing this until the end. Okay, so we keep doing this until the end. Okay, let's do this. Let's put this for a test run. Okay, let's take this for a test run. How do I take this for a test run? Oh, one more thing. Return arrows fired. Okay, so let's take this for a test run. Solution object. How do I can make an? I forgot how. Oh, new object. Okay, s equals solution. S dot points, and then points equals prints answer. Okay, so what we're doing here is we're gonna do this. Take this thing out for a test run. Let's see what happens if I run. Oh, gee, thanks. It doesn't run. God damn it. You know what? It's okay. We're gonna use Python Tutor. I really like Python Tutor because of the step through function. To my knowledge, it is probably the only web GUI that allows me to do that. Okay. So no self here. Let's run this. Visualize execution. Oh man, something's happening. Oh, next, edit code. I don't need this. Visualize execution. Okay, cool. So, 0 is not in list. Accept, return -1. Okay, excellent. see what's happening here. Let's go through this carefully. So max n is 16, popped because arrows fired 0. Let's go through this. Okay, so points.sort, that's the first thing we do. Okay, points.sort, and then this comprehension starts 0. Okay, so let's check that our starts and ends are correct. So starts is this thing over here, 1, 2, 7, 10. Yep, that's correct. Ends is 6, 8, 12, 16. That's what we want. Okay, arrows. Okay, 0. For A in range, max end. Okay, A equals 0. So find upper. That's not so that's not a problem, right? Ends is not in there. We're gonna fix that later on. Okay. What's our first end? Our first end is 6. So now A is still 1. So we'll keep going until A is 6. Can we like speed up a little bit? 3, 4, 5, 6. Oh, actually something is not correct because you see this A ends too soon. Okay. And I think it has to do with this break here. It's breaking out of too many things. Okay, we'll fix that. I promise you, chat. Okay, A is 5. 5 is not gonna work. Oh, A is 6 now. Okay, A is 6 now. So return balloon. Balloon should be 0. Return value 0. Yep. Because the 0, so balloon 0 has a right hand side of excuse me, has a right hand side of 6. Balloon 0 has a right hand side of 6. And so arrows fired is 1. So I'm firing at number 6. Okay, and then I'm going to pop all balloons whose start is smaller than end. So we go here. Int object is not iterable. Ha! And then it crashes. Wait a second. Starts. What is starts? Is this not how we do it? Oh, I see. It's not starts, it's enumerate starts. Ah, okay. This is a syntax error. So the reason why I said IDX is because I want both the index and the value. But I was wrong. You cannot just write it this way and expect magic to happen. Although, in my defense, I'm pretty sure you can do this in Ruby. You just can't do it in Python. Okay, cool. Now it looks a little bit longer. Okay, cool. Now we go back, A equals 6. Okay? We'll try to find the next balloon. Doesn't work. Okay, so arrows fired plus equals 1. Pop all balloons. Okay, IDX. IDX is 0. I is 1. That's correct. Because we start from balloon 0. Balloon 0's I, which is his left hand side, his start. Is okay, popped equals IDX. Yeah, so we're supposed to pop balloon 1. Sorry, or balloon 0. Coming back here, we're supposed to pop this guy over here. Okay, we're here, A equals 6. We'll pop this guy. Now we want to pop the next guy. We want to pop this guy also. Because 2 is smaller than 6. That was the error I made earlier. Okay, now we are at IDX 1, I equals to 2. I can do better with these names. Okay, let me just fix this over here also. Enumerates. Actually, I'll just copy paste later. And then now I equals index 2, I equals to 7. Okay, we are at this guy over here. Index 2, left side is 7. Because A is 6, we're firing at index number 6. We should not pop him. Instead, we should get out of the loop. We should not pop him, we break. Okay, so it goes back to here. And then we do a thing. This is really annoying, right? We're gonna fix this in a bit. You see A7. Let me see. What's the next one? Was next interesting A? Next interesting A is actually A. Oh, it's supposed to be A12. We're gonna see A10. It's not supposed to stop on A10 because of we're gonna check this popping thing. But let's see if it stops on A10. So A is 8, A is 9, A is 10. Okay. It's not supposed to stop here. It's supposed to say, oh, I found something. Wait, 10 is in list. Is it not in list? How can N 10 be not in list? Oh, I changed it. Yeah. So 12. It's not 10, it's 12. Okay, now A is 12. A is 12. Alright, we're going to find matching unpopped A12. It checks balloon index. It is in list. It is. So balloon 2, this guy, oh, this is actually originally was 8, not 10. So let's put it back to 8 so I don't confuse myself. So apparently it went to 8. So it was the tricky one because it is in the list of ends, but it's supposed to skip it since it's popped. Check this balloon smaller than pop thing. Yeah, it's done the right thing. So return balloon, yes. So now we get to the next place we're supposed to fire. We're supposed to fire here. Arrows fire equals again. So we're firing an arrow at number 12. Right, A12. We're firing arrow number 12. And this arrow is supposed to hit balloon 2 and balloon 3. Let's see if it does that. Popped equals index. So we hit balloon 2. Oh, we hit balloon 0 again. Oh, so this doesn't work. This might not work. Not sure. Oh, no, it does work. So we're popping balloon 0 again. We're popping balloon 1 again. Well, which is not quite right, but it's okay. We're popping balloon 3. 0, 1, 2, 3. Yeah, so we're popping all the balloons. Great. And then now we go back to this. And now we will never see. So A is now 13. We will never see. But popped is 3. 0, 1, 2, 3. So we'll never see another A again. So now this is correct. Okay. Let me just edit the code here. We're going to do enumerate. Enumerate start here. starts. Okay, and it's not just starts. Let me see if enumerate Python. Can I like start value? Okay, so the cool thing here is that I don't actually have to enumerate all the way from starts. I can enumerate from popped plus 1. No. Starts. I don't have to and pop plus 1. Okay, let me just submit this and see if it works. You must sign up and log in to submit. You know what? Let me just go off stream for a second. And switch users. Yeah. God damn it. So I'm trying to sign in to LeetCode, but LeetCode is not being helpful here. So I think I can sign in with Google. Sign in with Google. Yep. Okay, awesome. Oh god. Problems. Where's LeetCode 75? Minimum number of arrows. Okay, cool. And we are back. How do I get back? We are back. Okay, awesome. Cool. Now we are back. Now I can run. Can I run? Let's run it. Let's see what happens when I run it. Find matching unpopped. Do I have to make this a method? Self. Now I'm kind of annoyed. Self. I'm not gonna explain this right now. Not because it's not worth explaining. It's very much worth explaining, but that would take us down a different tangent. Next I. Okay, that's because we said. This should be correct, I think. It's gonna be a little bit slow. Oh, it runs. Let's see if it works. Fingers crossed. Wrong answer. Expected 4. Let's try this. Let's see what happened over here. I think it's one of those off by 1 errors. Let's go back to Python tutor. Well, you know what? Let's go back to Python tutor. Actually, can I run it? No, we can't. Not in the way I want it to. Okay. Let's Python. Realize debug. We are on the wrong screen. You're on the wrong screen. I can't see anything I did. Okay, cool. We're on the right screen now. What's this complaining about? List is not defined. Where did I use list? Oh. Ah. Okay. Let's run this visualize execution. Okay, cool. We're back to balloon popping. Okay. Oh, actually, we need to. Which one was wrong? Test case. This one is wrong. So let's see what's happening here. We set points to the test case that was wrong. Let's see if you can print. Balloon. Let's see if we can visualize the execution. So I want to see what's going on here. Okay, so far we have done 0 is not in lists. That's great. So who cares? Go next. Now 1 should be in list, because now our is 1, 2, 3, 4, 5, 6, 7, 8. So we have 4 balloons. They are sort of disjoint balloons. There's no overlap between them. Wait. Oh, yeah, this is fine. I'm looking for 2. Okay. So this is also a continue. Now we go equals to 2. Okay, so this should be A equals to 2. So balloon will be, what's balloon minus 1? Balloon should be 0. Yeah. So A equals to 2, balloon equals 0. Yeah, we're saying yes. Let's pop the first guy. Return balloon. Arrows fired. Okay, and now we're gonna pop. Okay. Popped. We're gonna go to, okay, IDX is 0. Index is 1. Yes, we're gonna pop this guy because our A is 2. And then now instead of index is 3, we're not gonna pop the guy. We're gonna break. Okay, our popped is 0. Yeah, so we pop balloon 0. That's perfect. Wait, how is this wrong? Okay, so it goes. Now A is 3. Yeah, so keep firing. So now A is 4. Okay, yeah, we found a second balloon, right? No, this is correct. This is great. Fire, okay, start. So popped is 0. So we're going to start from 1. Balloon 1, index is 1. Start of index is 1. Okay. Wait, why is start of index? Why is start index 1? So let's look at starts. Something is wrong with this enumerate. It's not doing what I expected to do. So we pop index 1. Oh, something is wrong with this enumerate. Let's try out this enumerate. Let's open another Python tutor. These guys are gonna love me for their click-through rate. I'm not gonna lie. Okay. 4 and x in enumerate. So starts is this one, 1357, and then popped is 0. Okay, let's just run it. 1 3. Wait, this is correct, right? Something is wrong here. Enumerates starts popped plus 1. Okay, so this is pop plus 1. Oh, not good. Oh, great, it's fine. Pop plus 1. This will give us... Oh, I see. I see what's happening here. It should not give us 1357. Wait, why is it giving us 1257 again? Oh! What does enumerate do? It's not doing the thing that I wanted to. Python, what does the start in enumerate do? It seems to start. Counter is to be started. Ah, okay. I see. So you don't, so when you enumerate, okay, this is something new to me. Okay, when I said starts pop plus 1, when pop is 0, pop plus 1 is 1, I wanted to give me 357. Okay, so when I run this, I thought it will give me 0 3, sorry, it will give me 1 3 2 5 3 7. So I'm just going to cut off the first two. But that's not what's happening here. I see. So that's on me. Okay? So that's on me. What I need to do, I thought that I'm just, when I say starts comma 1, it's just going to take out this row. But that's not what it's doing. So instead we have to use list slicing. So the way we're going to do this is, first we're going to get this enumerate 0 1 2 3, and then we're going to slice the list. List slicing. Okay, we're going to do this basically. We are going to get enumerate starts first, so we can get the indexes. But instead of starting from 0, we're going to start from popped plus 1 colon. And if I have nothing here, this means go all the way to the end. So this should give me this. which is what I want. Let's run it. Visualize execution. New array object. Oh, interesting. You know what? You know what? Let's just do this the old-fashioned way. I'm about done with wow, Python, you are not making a case for yourself. Okay? So we're gonna rewrite this. Instead of saying for index, we're gonna say for index in range popped +1 to length of stars. Okay? So we're gonna do it old-fashioned way. Of index idx equals to start idx. That's all. Very old-fashioned. So this should work. I'm sure there's a Pythonic idiom for doing what I wanted to do. I just don't know what it is right at this very moment. We can find out, but my stream might end soon once we're done with this. Oh, this still doesn't work. Output 3, expected 4. You know what? Oh, okay. Should this work? Still wrong answer. What about if I just do like, if I do the original one? If I popped all the balloons, would this work? This is what I was doing before, without the slight optimization. I just popped all the balloons starting from the beginning. I hope it does, because if it does, then I'm going to end my stream for today. If it doesn't, I'm still going to end my... damn it. What's wrong? No, is this not like this? Not like this. We still have some optimization to work on. So we're gonna work on this problem, continue working on this problem next time I come back down. Time limit exceeded. Okay, so I think what this tells me is that my answer is correct. But because of this A in range business, time limit is being exceeded. So yeah. So look at the case that I failed on. This test case is interesting. It's one balloon, but it's a very thick balloon. The balloon goes from 1 to 2, what is this? 2 billion. Okay? From 1 to 2 billion. Which means A goes from 1 all the way to 2 billion, and the whole time is just this one same balloon, right? So here, this is not correct. What I need to do instead of iterating one x-axis unit at a time, I need to jump. I need to iterate over n's. And we're going to talk about how we're going to do that the next time round, which is going to be this Sunday at 10 a.m. Fingers crossed. All right, cool. Thank you, Team Alex. Well, it sounds weird to call people Team Alex. Whatever you want to call yourselves.